Question 29. Is KOH an acid or a base? Amazing. Great. This is a question we can easily solve. Because we want to know how it dissociates first, okay? So, KOH, acid or base? Okay? So with that, let's actually write our formula. KOH, aqueous, breaks down into K plus OH minus. So with that, we have OH, wrong one. I don't know why I didn't switch. So we have OH minus. Right away, what do you remember about OH minus? That thing loves water. As in, if I put it with H plus, it turns into water. And you notice here, right, that it's two things becoming one. So there's a conjugate base, okay, and this is a conjugate acid, because the OH, okay, is now taking the hydrogen, the proton, and turning into water, okay? So with that being said, that makes KOH, because it has OH, a minus. KOH is not just a base, but it's a strong base, because OH minus is actually the strongest type of base you can have. So yeah, and let's see here into our acid base list. See OH minus all the way down here. Yes, it is quite a strong base to have. So KOH, K plus OH minus, OH and K, because K is also let's dissociate completely. They dissociate completely with each other, making this not just exactly a base, but a strong base. Okay. So with that, let's see what question we end with tonight. Hopefully something that we can actually solve. How can I write dissociation equations? So with this, actually, we can actually just use A, B's, and C, D's. So how can I write dissociation equations? So let's actually just use A plus B is equal to C plus D. Keep it simple for the last question of the night. So A plus B, C plus D. The way you write this, that's not a good example. Let's actually say A, B, A plus B. That's better, because you want it to be two things that dissociate into, one thing dissociates into two. The way you properly write this, okay, make sure you don't forget aqueous, but the arrow you put is not just one way, but you make sure you put its multi-directionality, unless you know for a fact that it dissociates 100%, like for example sodium. This is a correct way to show a dissociation equation. This here, okay, this right here is only for things that 100% dissociate. Examples are things like strong acids, most things bonded with sodium actually, so like NaCl. These things, in fact, I'm gonna make this all red if this can actually grab it. So yeah, I'm gonna make it all red. 100% dissociates. Strong acids, NaCl, this is that's it. But this is not. So not 100% dissociate. The most important thing here is really just the arrow, the signage, because you want to make that distinction. If they don't tell you that it 100% dissociates, it's usually safer to just put that type of double arrow, okay? So this one is actually, they use salt, okay? This one is 100% dissociation, okay? So the chemical equation, actually, as we show, the second one, where it says one arrow pointing turning into A plus B. So this is correct. But exactly, when you have things that are weak acids, so not 100% dissociate, so weak acids, you want to use this arrow here. The arrow is a key difference between 100% dissociating and not 100% dissociating. Okay, so this is correct. Let's put that. And with that, we went through all those questions for tonight. Just want to thank you again for joining me this stream. Hope you have a wonderful rest of your night and enjoy the weekend coming up. Thanks again, and make sure you check the links in the description below if you need any extra help or if you want to review any of the material we covered today, okay? And with that, have a lovely night and see you next time.